aircraft. Okay, so here's this model that we've been building. We already have parameter variation experiments in this model. And I'm going to show you, so we've been using them to do parameter variation simply with respect to stochastics. Okay, we ran it 10 times with fixed parameter values, and we accumulated the values. This was this first one we did. I don't know if you remember it, but we accumulated this type of information. Okay, and that's interesting. But we just had scalars coming out of this. These costs from realization were total accumulated costs over time. I would actually like to expand this with two things, okay? This existing one, baseline 50-year Monte Carlo. The first thing I'd like to expand it with is I would like to create a plot that would show the cumulative, the prevalence over time in the population, okay? And I want to see how spread that is. So let's go back to this model just so we can remember it. If you go back to main, I don't know why there's a my agent. I think I introduced that to explain something. Okay, let's go back to main. We're going down main. And ladies and gentlemen, if we go to main, we will find that within main, in the statistics area, we had some statistics. I would like to add in a prevalence of diabetes statistic. And you're going to tell me how to add that in. How do I do that? So I'm going to say fractional prevalence of diabetes. How am I going to compute that? Can anyone remind me? An average. Beautiful. Beautiful. Okay, that's just great. And what are we going to average over? Remember, it's 0 and 1s, right? It's 1 if they are what? Diabetic. Okay, so how do we test if a given person here is diabetic? Remember, this, we ask if they're in that state. Item.inState person.diabetic, all right? We need that person. And good, it's good to use many places. If they are diabetic, we're going to use what for them? 1.0, otherwise 0.0. Okay, so the fractional prevalence of diabetes. Are we okay with that? Okay, save it. And now I'm going to run a baseline for 50 years. Sorry? Sure, I'm sorry. I went up too quick. Yeah, sorry about that. So statistics, fractional prevalence of diabetes. Here we go. Item.inState person.diabetic, question mark.
Can you remind me what that code is?
Sure. If this person is diabetic, in the average, they'll represent 1, otherwise 0. And I argued, suppose there's 100 people, and 10 of them are diabetic, and the rest are not. Those 10 will each be 1s, will each be associated with a 1, and the other 90 will be associated with 0s. And so the average over it will be 0.1. Does that make sense? 10 are 1s, all the rest are 0s. So if you take the average over 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, you'll end up getting 0.1.
So I meant the question mark is another way of doing an if statement.
If statement. This is an if, it's like an if expression in R. Sort of, if this is true, use this value, otherwise use that value.
But sometimes we use a property statement.
Yeah, but this is not a statement. This is a formula. And this is, again, this key difference. A statement does something. It says, do this. That's where you need the semicolon. It's where you have a statement. If you just have something which computes a value, it's called an expression or a formula. This is just a formula. It's actually not telling it to do something. So we can't use an if statement. An if statement, it will choke up on. We can't use a statement here. We can't have something that assigns something or something like that. A statement does something different in its, an if statement does something different in its, if it's in its consequent and its alternative. In other words, if it is true, it does this. If it's not true, it does that. It doesn't return a value in Java. An if statement does not return a value in Java. We want something that is like an if expression. It returns a value. This returns 0 if the person is diabetic. Otherwise, it returns 1. Why is it so important it returns a value? Because we're taking the average over whatever this is for each person. Does that make sense?
But you could do it with an if function.
With an if function, yeah, you could.
I'd call it from here.
Yeah, you could have you could call a function, absolutely. Yeah, you could have a function, and then in that function it would say, if this, return this value. Otherwise, return that value. And because that function would return a value, it can be used as a call to it can be used as an expression. Yeah, the function call has a return value. You just couldn't use an if statement right in here. Yeah, okay? You could call a function which has an if statement in it as long as it returns a value. A statement by itself doesn't return a value. Okay, great. If only we had Scala. If only we had Scala. You don't know what good things you're missing. Okay, so this is our fractional prevalence of diabetes. Let us build it. Let us run it and just make sure we're cooking with gas. Okay? Here we go. There we go, ladies and gentlemen. And if we click here, we will see fractional prevalence of diabetes 0.009, 0.2, 0.71. Oh my gosh. Oh my gosh, ladies and gentlemen.
Which one are you running?
Sorry?
Which one are you running?
I was running the baseline 50 year. Yep. And it goes up, prevalent for that time frame, this is one cohort, actually rises to above 50%. The sad truth is there are cohorts like that in Canada that we study, where the prevalence of diabetes by age 50 is over 50%. It's an unfortunate thing. Okay, ladies and gentlemen, all's well with that, but now we want to read that out and we want to display it in our parameter variation experiment. We want to actually display over many runs how many yields different prevalences. So ladies and gentlemen, I'd like you to go to the Monte Carlo experiment. I'd like you to go to the palette. And I'd like you to drag in something you've never dragged in for this boot camp before. A histogram 2D. And good things often come in pairs, ladies and gentlemen. We're going to drag in a histogram 2D data called fractional prevalence histogram 2D, and then we're going to drag in a histogram 2D data chart. And guess on what it will depend. It will depend on the associated data set. So this data set is fractional prevalence histogram 2D, ladies and gentlemen. And then the chart is fractional prevalence histogram. Oh, I'm sorry. I made a mistake. The data set is called fractional prevalence histogram 2D data set, and the chart is called fractional prevalence histogram 2D. Okay? I'm really admiring your folks' wherewithal. I really admire your steadfastness. I greatly admire your stalwart characters. I think I told you, I had a student who seemed to just be eating up what I was teaching. He was very upbeat, and he was interested. It seemed like a real keener, as we say in Canada. Do you say keener here? No, you don't talk about keeners? Okay. Well, he was a keener. And I think Kurt met this keener, yeah. Anyway, he asked, I think it was on the last day of the boot camp, he said, do you ever have someone wig out in your in your boot camp? Do you ever have them, like, just go nuts and you need to have them taken away in an ambulance? And he evidently thought it was really intense in a way I didn't fully appreciate. He thought, someone could just lose it because it was too intense. So I admire, no one's wigged out yet. That's great. No, I appreciate it. And if you're getting too close to that, you could come talk with us. Okay.
If we push you so much that there's no energy left, that's fine too.
Okay, ladies and gentlemen, the histogram 2D, you'll notice that you have a choice between show envelopes and show bins. I would like you to show bins. Okay? This is going to summarize many, many runs, and it's going to show the fractional prevalence over time across many runs. Are we okay with that? Ladies and gentlemen, for data, we're going to do add histogram data, and we're going to say fractional, for the title, it will be fractional prevalence of diabetes. Probably I really should have called that fractional prevalence of diabetes, but that's fine for the data sets and so on. And the histogram, guess what this will refer? I'm trying to inoculate you about common misunderstandings. Guess to what this, when we say histogram, guess to what that needs to refer? To the data set. Yeah, it's a bit confusing because it says histogram. Well, this is the histogram, but no, it's to the data set. Fractional prevalence histogram data set. Boom. There we go. There we go. Okay, great. And data update, it says update data automatically. We don't need it to update automatically. Booyah. Okay. Okay, great. So we're, okay, now let's go set in the data set, the histogram 2D data set. We're going to say what the X value range will be and what the Y value range. The X value range is going to have, so sorry, this is for the data set, okay? For the data set. Okay, the number of intervals is going to be 50. Yeah, the data set 2D and a histogram 2D. Yeah, yeah. Okay. One time, I'll wait as people catch up. One time, Jeff came to one of my earlier boot camps, and I saw him on the last day. My boot camps used to be rather more intense. And I saw him on the last day standing in the back of the room with this dazed expression on his face. He was standing there and he said, "I think I am drowning in information." Because I was just spouting, sort of factoids and how you do this, how you do that. If you want to do this in calibration, you can do this. And it was just too much for him to absorb. And I think other people felt the same way. Okay, so ladies and gentlemen, between 0 and 50, okay? And it was too intense. It didn't serve a purpose. Now it's much more hands-on. Okay, y-axis value range is going to be 20 is fine. And it'll be from 0 to 1. Because we're going to be plotting the prevalence, the fractional prevalence. We'll go from 0 to 1. But the X value, guess what that will be? For the time. The time, ladies and gentlemen. The time. Okay, are we ready? Who needs a bit more time? I'm sorry? To the Y? Yeah. Okay. Okay. Are we ready?
The X value, the X is time.
The X will be time.
Y
is the fractional prevalence. And what this is going to do, Julia, it's going to summarize over many, many runs, like what fraction of those runs for the certain time, what fraction fell in different ranges. So we're going to be able to get this as like a summary of many, many runs. Okay? Ladies and gentlemen, okay, and you can see the coloration here. It's going to be darker if many runs fell in there. It's going to be lighter if few. Okay, by the way, 2D histograms, there are other things you can produce in R, for example. It's quite nice. They have colored 2D histograms. And sometimes we can export data from, we'll export data from AnyLogic models to that. Okay, ladies and gentlemen, we're going to go now and, for for the data set as well, we're going to say do not update data automatically. Okay? Okay. Okay. Now, finally, we're going to go to the Monte Carlo itself. This is, again, the baseline 50-year Monte Carlo, not the ICER Monte Carlo, the baseline 50-year one, right? And we are going to go down to the Java area. And for the initial experiment setup, we're going to clear this data set. This fractional prevalence histogram 2D data set dot reset, okay? We're going to reset this data set. In case we run it many times, we don't want it to overwrite, to just keep the old values. We want to clear it out, flush it, spring cleaning. Okay? Okay, next, ladies and gentlemen, we're going to do the following. Yeah. So up here in initial experiment setup, we're going to do this fractional prevalence histogram data set reset. In other words, we'll go clear this out. We're going to clear it out, Joe. Just flush it all. Are we okay with that? Would you like a little bit more time? Okay, ladies and gentlemen. Okay. Now, I need to go refresh something in my mind about this model. Did we, in the model in main, did we have a data set for fractional prevalence? Did we accumulate that? No, we didn't. Okay, we need to do that. I'm sorry, folks. So we need to go back to main. We need to go down main, and we need to add a data set in main to accumulate the fractional prevalence over time. So we're going to go into main and add a data set, and this will be called fractional prevalence data set. Fractional prevalence of diabetes data set, because it could be fractional prevalence of obesity for all that matters.
So because I added that into the other one by mistake, can I cut it and paste it?
Yes, you can. Yes, you can.
And it'll run to main, okay?
Yes, you will. Yeah, it will. In general, AnyLogic is pretty good about cutting and pasting things around. Okay, ladies and gentlemen, fractional prevalence of diabetes data set, we have it there, and we are going to do not update data automatically. It'll say find the 100 latest samples. The only thing we want to do, okay, maybe I will tell it automatically here, okay? In this case, we'll update data automatically. And guess what we'll take for the vertical axis value? In this case, we're telling it, hey, update yourself. No need for a event. What do you think we should do here for the vertical axis value?
0.
Yeah, we're going to actually call off to what? We're going to store away the fractional prevalence. Where is that computed? In the populations, in what in the population? Statistics. So ladies and gentlemen, this is what we want. For this new data set, we're calling it fractional prevalence of diabetes data set. We put into the vertical axis value this call. This is asking the population to compute this statistic. And we want to do update data automatically. Okay? Update data automatically. It's going to update every, just look down below, every 1 year. Okay? It's going to update every 1 year. Do you see that? Okay. Okay, and now, having done that, can. Up. Oh. Okay. Okay, now let's go back to this experiment. And ladies and gentlemen, after the simulation run, after we did these qualies things, guess what we're going to do? We're going to now extract the time series of prevalence and put it into the histogram 2D. By the way, I have a whole series of step-by-step examples and then a number of challenges, like to try challenging yourself with AnyLogic too. You folks might be interested in those. I should really liberate those for your use. And actually, I have solutions to them to provide those, and then you could try those out. Okay. Okay. Maybe I can get my TAs to poke me on that.
What are they poking you about?
Poking me about extracting my challenge exercises. Okay. So this is what we need to do, ladies and gentlemen. We need to add in the fractional prevalence data set from Maine. We need to add it into this 2D data set. Okay? So here we're going to go. We're in the experiment, the Monte Carlo experiment, right after this, and we're going to do this. Mark my words. This fractional prevalence histogram 2D data set, and we're going to say add, and look at that, ladies and gentlemen. Look at that. We can add in a data set. Okay? Great. And what data set will we add in? Riddle me that. Yes. Whence will it come? It will come from Maine, but we can't say Maine. What do we have to say? Root. Root. See that? Yeah, computer scientists use this term root a lot. It actually means several different things. But root in a like a tree means like the place from which all other things, from whence things come. Okay? Okay. It's like the place where it branches to many different things. And we talk about the root of a file system, but also someone can be root on a computer system. That's a different root concept. Dylan will sometimes go in as root to his computer, right?
We really like to overload things, don't we?
Yeah. Okay, ladies and gentlemen, so this root is referring to Maine because it's kind of the thing under which all else lives. That's why it was named. It was named, one recognizes the lion by his claw. It was named by a computer scientist. Okay, so we're going to extract from Maine this data set. Where did this data set come from? Who created that? You did. Not 5 minutes thence. Right? Yeah. Okay. We did that, and we're adding it into this 2D data set, ladies and gentlemen, into the 2D data set. Okay? And that, ladies and gentlemen, should complete that exercise where we added this 2D data set. Now, I actually secretly am concerned about one thing, but let's observe and see what happens. Okay? Okay. There we go. Look at that. What is that illustrating? Indeed. And look, there's some variability about it. Okay.
Your random seed's not turned on, is it?
It is.
I mean, the random seed is, yeah.
You are.
Okay.
Is it like a confidence interval or a range?
It can give empirical factor quantiles. In fact, we'll see how you can export data, and that will help understand the data. So this is summarizing over many, many runs. There were a few runs where it went up to here early. There were a few runs where it remained down here this late. But this is summarizing. Sort of over all those experiments. Now we only ran it 10 times, but it gives you a flavor. I'm going to do copy all. Right click and do copy all, and I'd like you to go. You could also see it through this, alternatively. But ladies and gentlemen, I would like you to now go to Excel, And if you call up Excel, I'm going to just create a new sheet. And here's what's in that. It's what's in that. So what this is saying is, what do you think these things are up here on the top? These are times, like this is from interval from 0 to 1, from 1 to 2, and these are the intervals of what on the y-axis? Fractional prevalences. And so you'll notice like two of the 10 realizations, I know because I ran 10, 2 of the 10 realizations. Why do I say 10? Because it had 10 realizations here. 2 of those 10 realizations by time 10 to 11 already were up at 0.1 prevalence. But 8 of them are still down here. And then, 4 to 6, 2 to 8. Okay, by the time that we reached 13 to 14, all of them were here. And you could see they crept up. Now, clearly, the resolution here depends on things that we can set. So, these are rather coarse divisions. So let's actually make this finer if we could, okay? I'd like to divide it up into finer categories yet. So maybe we'll bring it up into, instead of 20 along the y-axis, we'll bring it up into maybe 100. So how would I do that? Whither would I go? Sorry, to the data set, indeed. And how would I set it to the X bins? How many Y bins there are, rather? Yeah, 50 interval, sorry, 100 intervals. 100, ladies and gentlemen. What if I were to frob the number of X intervals? What would happen there? You got it. It's only putting it once a year, so it really wouldn't be helpful. We'd have to go back and change that if we really wanted extra resolution there. That's not the rate limiting factor. So that would be frobbing it unnecessarily. So you don't want to frob that. But this one, 100 intervals from 0 to 1, that one can be fruitfully changed, okay? So here we go. Okay. So we learned from Wikictionary that my dialect for using frob is slightly off, ladies and gentlemen. The Wiki dictionary was saying frob means to kind of aimlessly tweak. And so I was using it just to mean kind of to tweak in general. So I stand corrected. So here we would have been aimlessly tweaking. Okay, so now you start to notice divergence. Did you see that? Like the first couple here, I'll start running it again, okay? Here we go. Okay. So now we have resolution, and obviously this would yield much more interesting results if we were to. I'm going to zoom in here. If we were to run it many more times yet, but watch this if you could. Okay. Here we go, and there's one run. And here along a second one. You could see there's a certain amount of spreading betweenst them, right? There's some that are slightly higher than others in terms of the prevalence. By the luck of the draw, how many people are getting developing diabetes over time? Okay, this can summarize the outcomes, in terms of variability. Yep. Why what? Why are some? Oh, because the dark ones mean more runs went through there. That counts the number of runs where they fell in that area. So this is a high density region where this is a lower density region?
Yeah.
Good or not? Okay, great. Excellent, ladies and gentlemen. Okay, so now, ladies and gentlemen, I'd like you to right click on this guy, do copy, and now I'd like you to go up and do paste at the top. How did I do that? I'd like you to right click on this guy and do copy, and then at the top I think I'd like to do paste. Okay, and here I'm going to call this baseline 50-year month. I'm going to call it 50-year parameter variation. Okay, we're going to do a parameter variation experiment, literally varying the parameters now. Now, for varying the, okay, really I should save this and upload it.